Welcome to Senior High School Math Series. In this video lesson, let us discuss z-test for a proportion under statistics and probability. Many hypothesis testing situations involved proportions. Recall that a proportion is the same as a percentage of the population. Before we continue, let us ponder on this. These data were obtained from recent news articles. 63% of Filipino prefer COVID-19 vaccines from the United States. 79% of Filipino adults believe that violators of minimum health protocols are the real cause of the current spread of COVID-19 in the country. 40% of currently married Filipino women aged 15 to 49 are using modern methods of contraception. 21% of Filipino adults use Facebook daily as a source of news. A hypothesis test involving a population proportion can be considered as a binomial experiment, when there are only two outcomes and the probability of a success does not change from trial to trial. For a binomial distribution, we may recall that the mean is given by mu is equal to the product n times p, where n is the number of trials and p is the probability of a success. And the standard deviation is given by lowercase sigma is equal to the square root of the product n times p times q, where q is 1 minus p, or the probability of a failure. The formula for the z-test for a proportion is given by p hat minus p all over the square root of the product pq over n. In here, p hat is the sample proportion, p is the population proportion, n is the sample size, and q is equal to 1 minus p. Let us have an example for z-test for a proportion. A news article states that around 53% of the Filipinos support the passing of the divorce law in the country. A student researcher randomly selected 220 people and found that 112 people stated that they support the measure. At alpha equal to 0.01, test the claim that less than 53% of Filipinos support the passing of the divorce law in the country. In doing z-test for a proportion, we follow the same procedure in performing z-test for a mean. The only difference is the formula for the z-test value. Let us begin with step 1. State the hypothesis and identify the claim. In this problem, the null hypothesis p is equal to 0.53 and the alternative hypothesis p is less than 0.53, that is from 53%, and this is the claim. For step 2, we find the critical value. At alpha 0.01, the test is left-tailed. Then we have negative 2.33. Therefore, the critical z value is negative 2.33. For step 3, we compute the test value using the formula given in the previous slides. From the given information, we have the population proportion as 53%, so we have 0.53. To get Q, that is 1 minus P, or 1 minus 0.53, so we have 0.47. To get the sample proportion, we get the ratio between the number of successes and the number of sample. X is 112 and N is 220. Then this is equivalent to 0.509, and that will be our sample proportion. N is equal to 220. Substituting these values to the given formula, we have ztest value is equal to 0.509 minus 0.53 all over the square root of 0.53 times 0.47 over 220. Using our scientific calculator, we press fraction and then 0.509 minus 0.53 divided by the square root, 0.53 times 0.47 divided by 220. Press equal sign, then this is negative 0.6240. Then the z-test value is negative 0.624. Now we proceed to step 4, and that is making the decision. Our z-critical is negative 2.33, that is obtained from step 2. So we have alpha 0.01, and this is our rejection region or the critical region. On the other side of the z-critical value is the non-critical region. The test value of negative 0.624 is greater than the critical value of negative 2.33. Hence, it is on the non-critical region. Therefore, the decision, do not reject the null hypothesis. This time, let us summarize the result in step 5. Recall that in step 4, the decision is do not reject the null hypothesis. And from step 1, the claim is the alternative hypothesis, that is P less than 0.53. Hence, there is not enough evidence to support the claim that less than 53% of Filipinos support the passing of the divorce law in the country. Let us have example number 2. A barangay health official claims that more than 25% of current smokers in their barangay plan to or are thinking about quitting smoking. A researcher randomly selected 200 adults from the barangay who admitted that they are currently smoking tobacco and found out that 63 plans to or are thinking about quitting smoking. At alpha equal to 0.05, is there enough evidence to support the barangay health official's claim? Let us proceed with the hypothesis. Null P is equal to 0.25 since the population proportion is 25%. The alternative hypothesis, P is greater than 0.25, and this is the claim. For step 2, since alpha is equal to 0.05 and the test is a right-tailed test, the critical z value is 1.65. Step 3, we compute the test value from the given information. Population proportion is 0.25. Then we have 1 minus P is equal to 0.75. The sample proportion is equal to 63 over 200, and this is 0.315. N is equal to 200. Substituting these values to the formula, we have 0.315 minus 0.25 over the square root of 0.25 times 0.75 over 200. Using our scientific calculator, we can get the z-value or the test value as 2.12. From step 2, the critical value is 1.65, and from step 3, the test value is obtained as 2.12, which is greater than the critical value of 1.65, and this is in the critical region. Hence, the decision reject the null hypothesis. For the last step, there is enough evidence to support the barangay health official's claim that 25% of current smokers in their barangay plan to or are thinking about quitting smoking. Let us proceed to example number 3. An election officer claims that 60% of the voting population in the 2nd District of Caloocan City are aged 40 years old and below. She randomly selected 200 people and found that 128 people stated that they are 40 years old and below. At alpha equal to 0.05, is there enough evidence to reject the election officer's claim? Step 1, we state the hypothesis. Null P is equal to 0.6 and the alternative P is not equal to 0.6. And the claim is the null hypothesis. For the critical value, since alpha is equal to 0.05 and the test is a two-tailed test, then the critical values for Z are positive 1.96 and negative 1.96. For step 3, we have P is equal to 0.6, that is the population proportion, and Q is equal to 1 minus 0.6, 0.4. The sample proportion is given by 128 over 200, and that is 0.64. The sample size is 200. Substituting these values to the given formula, we have Z is equal to 0.64 minus 0.6 divided by the square root of 0.6 times 0.4 over 200. Using your scientific calculator, we have 1.15 for the z-test value. From step 2, the critical values for Z are negative 1.96 and positive 1.96. The test value is 1.15, which is in the non-critical region. Hence, the decision do not reject the null hypothesis. To summarize the result, there is not enough evidence to reject the election officer's claim. That will be all. Thank you for watching. Please subscribe for more math lessons.